Next speaker is Katie. She's a cloud-native leader, practitioner, and contributor, currently at Apple and Cloud Native Computing Foundation. As a cloud platform engineer, Katie has built the infrastructure for Condé Nast and American Express, gravitating towards cloud-native technologies, principles, and Kubernetes at the focal point. She's also very active in promoting women in STEM, and because we're late, I'll invite her to the stage.
Hello, everyone. Let's just check if the clicker is working. Awesome. So my name is Katie Gamanji, and currently I am a senior field engineer for Apple. I have joined Apple last year, and my role, I'm trying to bring Kubernetes and cloud-native expertise to different teams and products within Apple. As well, I am one of the TOC, or Technical Oversight Committee member for CNCF, or Cloud Native Computing Foundation. In this role, I am joining 10 other champions within the industry, and I'm trying to provide a technical guide for the cloud-native landscape. I have many other roles in the community. Currently, I'm an advisory board member for Captain, which is a sandbox, actually incubation, CNCF project, and I am the creator of the Cloud Native Fundamentals course, which you can find on Udacity. Now, this is a free course. You don't have to pay for it, but if you have an interest in Cloud Native, I definitely recommend taking this and understanding those Cloud Native principles that you can apply. Today, however, I would like to reverse engineer Cloud Native, and more importantly, I would like to focus on interoperability and community. And to do so, I would like to focus on the first part, which is going to be the emergence of interfaces. Here we're going to look at how the containers became globalized, but more importantly, how we have the interoperability principle at the base of our landscape. Now, interoperability, in a nutshell, is embracing multiple solutions for the same problem. And I'm going to focus on some of the interfaces that prompted that interoperability principle to be applied. So I'm going to talk about networking, runtime, storage, service mesh, and many more. Now, it's very important to have technology. However, when it comes to open source, it's all about community as well. So we need to build a sustainable community. And here I'm going to showcase how can we build the next generation of cloud-native practitioners, but more importantly, how we can further diversify our executive leadership. And towards the last, I would like to bridge the gap between cloud native and data science to actually make it relevant for both of us. So pretty much, we're going to answer the question, can we do data science in a cloud native way, or can we do cloud native in data science? So the short answer is going to be yes, and I'm going to showcase some of the tools that fall into that kind of union. Now, for anyone here, how many of you have heard about cloud native or had any interaction with it before? Ooh, okay. How about Kubernetes? Has anyone heard about Kubernetes? Containers? That's good. Thank you. Awesome. Okay, I'm a bit relieved. Now, Kubernetes might be a familiar area. However, some of you might still be quite new to the cloud-native world in general. So I would like to take a step back, maybe 15 years ago, and understand why containers actually became popular nowadays. Ooh, oh, that's interesting. The formatting of the slides is a bit off. So I promise I can spell. So it's container primitives. That's what is the focus of this slide. Now, to run successfully a container you can think about this as an instance of your application. To run an instance of application or a containerized application, you need two primitives, cgroups and namespaces. The cgroups pretty much will impose the limits for your container, so how much CPU and memory you can use. Namespaces on the other side focus on the process resources, what the process can see. So think about other processes, for example, the file system, directories and other files, any mounts, networking, and so forth. However, these two primitives have been in the Linux kernel since 2008. Kubernetes became popular maybe 9 years ago. So what happened in those 5 years? This is a question that we need to answer ourselves. Well, pretty much the answer is going to be quite straightforward. Technology is a competitive edge for every single organization out there. And for you to deliver value for your customers, you need to solve 3 challenges. Doesn't matter what kind of industry you work in or what kind of organization you're part of. The first challenge is going to be application complexity. Now, in a service or like in an architecture where we have multiple microservices, we introduce the simplicity of developing different components. However, the challenge is going to be that we still have thousands or hundreds of microservices we need to deal. So the scale is still a problem. The second challenge we need to think about is fast deployments. This is an imperative nowadays. The faster you deploy, the better, the faster you're going to have a customer value. And this will translate into growth of your business as well. And the third challenge is going to be environment uniformity. So how can we minimize the delta between your local environment and production? Well, luckily, we have container orchestrators. I should have checked that. So this is container orchestrators, at least what it's supposed to say. In between, we actually had Docker, which was a very important tool to kind of globalize the usage of containers. However, we still have a challenge. How can we manage thousands of containers in production? And more importantly, how can you do that at scale in different regions for different markets? So if you look 9 years ago, we had multiple container orchestrator frameworks, such as Docker Swarm, Apache Mesos, CoreOS Fleet, Kubernetes, and all of them provided a viable solution to run containers at scale. However, Kubernetes took the lead in defining the principles of how to run containerized workloads. Nowadays, Kubernetes is known for its portability and adaptability, but more important for its approach towards declarative configuration and automation. And we can see this in numbers as well. Based on the VMware Townsend report, State of Kubernetes, 99% of the organization see a clear benefit of adopting Kubernetes. The first one being a better usage of their CPU and memory, so their resources, and the second one being a better application management, especially when you have to upgrade. Because if you have a new version of your application, you just need to update the tag for your image, and the rollout is going to happen automatically. Well, it's going to be handled by Kubernetes. Another metric I would like to point your attention towards is that 52% of the organizations have a need for bare metal or Kubernetes on bare metal. Now, what it actually means is that now we have a critical mass in adoption, and we have enterprise organizations that are tapping into the Kubernetes world. And for these organizations, the main characteristic is that they're regulated, which means they should have a full understanding and ownership of their data and infrastructure. And another metric I would like to draw your attention towards is that 88% of the organizations actually operate more than 6 clusters. So what it actually means is that once you deploy one cluster, it's a very steep learning curve. It's a difficult task to do. But once you achieve it once, do it once, you'll be able to replicate that. So you're going to have different environments. You're going to have a dev, supposedly staging, maybe QA in between, and production. And that's just 4 clusters you have to manage for one availability zone. And this grows exponentially, as you can imagine, if you'd like to replicate that, for example, in the US or APAC and other regions as well. However, this growing community around Kubernetes has been extremely beneficial for it because over time we had multiple tools built around it. For example, support for different networking systems and support for different storage systems. And this created what today we know as the cloud-native landscape, which resides under the CNCF umbrella. Now, I mentioned the TOC role. This is the landscape that the TOC pretty much tries to steer. But more importantly, we try to take the projects for different maturity levels. So there are 3 maturity levels that I'm going to refer today quite often. We have sandbox, incubation, and graduation. Sandbox means the project is still very greenfield. It can have potential to influence different areas in the ecosystem, but it doesn't have that critical adoption yet. Incubation is a project that is quite mature. It's proven its worth in the production system and already has some diversifications in organizations that contribute to it. A very important thing is that we want unbiased contributions. We don't want one organization to take lead of the entire project. That's a biased roadmap. We want to remove that completely, so we want to diversify the contributor base. And when we reach the graduation, that's the state of the maturity that every single project wants to reach. You have been working in production very well. You have adopters across different industries. And more importantly, you have a roadmap that's sustainable. So you have different features that can be deployed and further kind of prove this maturity of your project. And let's see. I think the slides today, let's just not focus on that too much. So to actually reach the state of the art, so to actually reach this very extensive cloud-native landscape, the story at the beginning was very different because the community was not as flourishing and it was not always as engaging. So now we know that Kubernetes is able to provide the environment for application execution while shrinking its footprint in the cluster. It's all about efficient use of your resources. But to reach the state of the art, we had two challenges to solve first: networking and pretty much hardware. How can we schedule our workloads anywhere and how we can connect to them? And these two challenges were solved by two interfaces: the container network interface and the container runtime interface. And I would like to pretty much focus on these two areas because they're quite pivotal into how the landscape is in the shape it is today. This is pretty much highlighting the interoperability principle and why we need multiple tools for the same problem space. So let's focus on networking first. Now, exploring the networking fabric within the cluster is quite challenging. The way Kubernetes runs, it actually has workloads on a distributed amount of machines, but it ensures that reachability and connectivity to these workloads is going to be continuous. As such, the networking topology is highly assertive, and it gravitates towards the idea that every single pod has a unique IP. Now, some of you are familiar with Kubernetes, so pod is quite a self-explanatory element, but I'm still going to explain it. It's pretty much the atomic element within the Kubernetes cluster. In a pod, you pretty much have a container. Ideally, it's a one-to-one mapping. Sometimes you can have two containers. Depends if you have a sidecar model. But usually, you can think about a pod as an instance of your application. Now, whilst having this networking topology removes the need for dynamic port allocation, we still have new challenges that come into light, such as how can we connect to other pods, services, and how can users access our application. And to actually showcase why we need an interface, let's go through an example of how a networking packet is pretty much sent from application on a node to a different application on a different node. Now, you can think of a node as an instance, a VM, any amount of compute that has the kubelet installed on top of it. And kubelet is pretty much just the Kubernetes agent, pretty much saying that this machine is part of the cluster. Now, we have a networking packet that's going to be sent from a pod. The first thing that's going to happen is going to look inside the pod. Remember, in a pod we can have one or two containers. Depends on the model that we use. For the sake of this example, we'll not be able to serve the request, which means it's going to go out from the pod to the root network namespace of the device. At this stage, we have visibility of the entire suite of pods that we have on the machine. Again, we'll not be able to serve our request, which means we're going to go outside of the root network namespace for the Ethernet device towards the routing table. And this is the important component, because the routing table has the mapping between every single machine and the CIDR of IPs that should be allocated on that node. So that means that with minimal hops, we'll be able to identify our machine and in a reversive manner go through the Ethernet device to root network namespace/pod to serve our request. Now, the routing table is a very important component here because in Kubernetes, we want every single application to be reached by its IP. And to fulfill this requirement, we had to integrate support for different networking systems. And this is why we had the Container Network Interface, or CNI, appearing. And it pretty much concerned itself with allocating a pod with an IP and removing the resources when the pod is not there anymore. Now, the interoperability principle. We have a lot of tools focusing on the networking space. I just put 3 here. This is not an exhaustive list. There are many more. But more importantly, we can see that we embrace different solutions for the networking space. So Flannel here is known for its simplicity to provide that network overlay for a cluster. Now, if you care about kind of configuring the access to your services in a bit more detail, you can use a tool such as Calico, because in addition to the network overlay, it comes with a network policy enforcer, which allows you to configure who and how can access your service. And if you care about security, you'd probably look at a tool such as Cilium, that in addition to the network overlay, it allows you to configure configure packets at the layer 3 and layer 7, so pretty much networking and application layer. Now, the second challenge we had to solve is how can we pretty much put our containers anywhere? And this is something that the runtime is going to take care of. And the story here is a bit different because the capabilities for runtime, they were provisioned by tools such as Rocket and Docker. And this logic was very deeply ingrained within the Kubernetes source code. Now, again, runtime is pretty much a component that takes any request from the kubelet. The kubelet is the Kubernetes node agent, and it will make sure to create the pod with the right specification of the machine. So for example, you want a pod or your application to consume this amount of CPU or GPU in your case, this amount of memory, you want this kind of security principles put on top of it. So pretty much all of the specifications are going to be provisioned or ensured by the runtime. Now, as I mentioned, the logic for these components was very deeply ingrained within the Kubernetes source code. And then we had two challenges with that. The first one is a very low velocity rate for new features. So if you develop something new, and you actually release it, they actually have to be released with the Kubernetes binaries, which is a very lengthy process. So you have to wait a couple of months to use your functionalities in production. Another challenge was when you want to integrate new runtime components, because as an engineer, you require a very in-depth knowledge of the Kubernetes source code. And this is not sustainable, and by default, it was understood that we need an interface. As such, we had the CRI, or Container Runtime Interface, appearing that provides this network overlay or abstraction of runtime within a cluster, from which Docker and Rocket are just some of them. Again, the interoperability principles. We have multiple tools covering this space when it comes to runtime, from which we have Containerd and Cryo being some of the most widely used, mainly because of their industry standard to provide a runtime capability. Very important to mention here, Containerd is a graduated CNCF project. Cryo is an incubating CNCF project. Now, I've put gvisor and Firecracker here as well, and these are runtimes that are provisioned by vendors. It's only natural to allow cloud providers to use their own API to create the containers on their own infrastructure. As such, Google has their own runtime, which is going to be gvisor, and AWS is going to have their own runtime, which is going to be AWS Firecracker. Now, so far, we can see that at the beginning, at the genesis, the landscape embraces multiple solutions for the same problem. And this was extended to other spaces as well. Now, from now on, the community concerned itself more and more with the extensibility of Kubernetes, rather than being very biased on the amount of tooling or what kind of tools you use. And we can see that implemented on the service mesh, container storage interface, and cluster API. And very briefly, I would like to go through this as well. Now, service mesh interface was introduced in KubeCon Barcelona in 2019, and it pretty much democratizes the way we introduce a service mesh within a cluster. Now, for anyone new here to service mesh, pretty much is a dedicated infrastructure layer that concerns itself with the traffic sent between two different services. So pretty much, when you have a request from a user and you have multiple microservices, the request is going to go from multiple microservices from 1 to 2 to 3, but you want to recreate that entire journey to make sure that it's actually fulfilling the desired behavior that you want. Service mesh will be able to recreate that journey, and it will be able to provide telemetry on top of that as well. And some of the tools that are integrating with SMI, or Service Mesh Interface, are Linkerd and Istio. We have Console and Open Service Mesh and many more. Now, Linkerd currently is a graduated CNCF project, and Istio quite recently was pretty much allowed into CNCF as an incubating project. Not allowed. They actually reached the incubation stage. Now, if you look into the story is very similar to runtime. Its logic was very deeply ingrained within the Kubernetes source code. Same two challenges: very low velocity rate for new features, and a very high level entry bar for new services, storage services. Again, an interface was necessary, and that's how the service mesh interface was introduced. It was actually introduced in Kubernetes 1.9 in its alpha release, and it moved to GA in Kubernetes 1.13, so quite a steep kind of graduation. And we have tools such as Rook, Ceph, OpenEBS, and many more. There are more than 60 providers in this space, and this is one of the most developed area in CNCF. Again, worth to mention here, Rook, graduated CNCF project. And the last interface I would like to showcase is the cluster provisioner interface. Because when I talked about networking, runtime, service mesh, and storage, all of these are within a cluster. All of this is pretty much resources that you can choose and plug within a cluster. Now, Cluster API was a tool that took the idea of interfaces a further step. Pretty much how can you create your clusters anywhere, be it on bare metal, be it on a public cloud provider such as GCP or Azure, or even Chinese providers such as Alibaba Cloud and Baidu Cloud. Now, at this stage, we know we can have multiple tools to plug into our system. We can create our clusters anywhere. We need observability. Again, very, very essential. We needed to provide some kind of standardization the way we collect and aggregate our data. As such, we introduce open standards within the observability stack as well. We want to simplify instrumentation, but at the same time, to lower the cost of aggregating our data. That's why we had two initiatives here, Open Telemetry and Open Metrics, that concern itself of how to collect and aggregate metrics at scale. Open Metrics, currently incubating CNCF project. As you can see, we have a very good maturity level across all of these open standards. And the last thing I would like to mention here is how can we improve our application deployment? Because currently we have multiple tools. As you can see, as an engineer, you don't need to take care only of the Kubernetes cluster. You need to take care of your networking component and runtime and storage. And there are so many components that you need to be aware of. We need to simplify our developer experience, and we need to enhance that as much as possible. And we have tools such as kubevela, Crossplane, and Backstage trying to tackle this space. Now, with kubevela, they try to pretty much abstract the full configuration file. So pretty much you just say, I want an application running on this port without actually taking care of any Kubernetes resources. Crossplane, on the other side, tries to extend Kubernetes API for custom resource definitions. And this is where we actually say that, for example, you want a database instance to run and you have that tailored workloads. And Backstage currently is focusing on providing a developer portal. So pretty much abstracts all of the terminals from you and provides an interface for you to interact with your cluster. Worth to mention here that kubevela currently is a sandbox project and Crossplane and Backstage incubating projects. Now, as I mentioned, so far we focused quite intensely on exploring how the cloud-native landscape was created from a technical perspective. We have multiple interfaces and open standards that help us to develop new tools in a way that we're not biased in terms of tooling, but we can choose what's right for our software. However, when it comes to open source, technology is a gravitational point. However, we need community to make it happen continuously and sustainable, so pretty much to keep it alive. Well, one of the things that was very important when it comes to cloud native is that we have open governance, and we have a principle that inclusive is better than exclusive. We try to create a space where every single feedback or idea is valued, and it can be constructed or integrated in a technical way within the landscape. Now, some of you might be new to cloud native, however, you can already contribute. And I definitely invite you to check the contribute.cncf.io, which will have all of the projects that you can get involved right now. Now, the thing is, you don't need to write code to be a contributor. This is a very important message that I would like to leave with you. Within the CNCF, we have different tags or technical advisory groups. We have significant interest groups and working group, many other groups, to be honest, that you can get involved. But you can see some of the areas that overlap with our interfaces. So for example, we have tag network, and we have the CNI. And pretty much with the CNI, we had a micro ecosystem which was developed just for networking, and a tag is going to take care of that. There is security, there is storage, runtime, observability, and many more. The most important thing about this, you can get involved right now. Everything in terms of the mailing list, the public calls, the agenda notes, everything is public and available on GitHub. So if you're interested in any of these areas, you can join them straight away. There is no kind of gatekeeping or any exams you have to take to reach that. But more importantly, I think as a community, we should grow at the same pace with technology scale. And this means that we shouldn't just focus on solving the problems that we have in the present. We should focus on creating a culture of upskilling and education where actually the next generation of practitioners are going to be kind of thriving in. And for that, we have 3 professional certifications that I'd like to mention: CKAD, CKA, and CKS. So pretty much certified Kubernetes application developer, administrator, and security specialist. However, to take these exams, you need pretty much the exam is a terminal and you have to write the commands. So if you don't know how to interact with Kubernetes or how to get the right answers, it's a fail. So the feedback from the community was this is not very inclusive, especially for students or people who are new to cloud native or people who want to just make a career change and move to cloud native. Well, as part of that feedback, we've heard it, and we've created the KCNA, or Kubernetes and Cloud Native Associate exam. And I'm one of the creators for this exam as well. Now, this is a multiple choice entry-level examination that pretty much allows you to demonstrate your knowledge and passion around cloud native. And again, as part of my personal mission of making cloud native ubiquitous and lowering the bar to entry for everyone, I have created the Cloud Native Fundamentals course, which you can find on Udacity. Now, this course, again, all you need to do is to know how to write some code. But I'm going to take you through the journey of containerizing your application using Docker, creating a cluster, and applying all of these cloud native principles. Now, as a community, it's very important to remember that we build software that changes entire industries and sectors out there. However, we still need to do better when it comes to diversity. We still need to diversify our executive leadership, technical committees, governing, and advisory boards. As such, you're a part of the community, you're part of an organization. I would like to encourage everyone to continue building a diverse community. And as mentioned, I would like to bridge the gap between cloud native and data science to actually make this relevant for all of us and actually see if we can do data science in cloud native or apply cloud native in data science. It depends how you want to look at it. Now, when it comes to cloud native, it's all about building scalable applications that are observable, declarative, and more importantly, agnostic in terms of the platform you can use. Data science is all about getting engineering value out of data. So you pretty much want to understand and analyze different behaviors and different functionalities through data. Now, can these two be combined? The answer is yes. And these are some of the tools that you might be familiar with, or I hope you're going to learn more about them. But more importantly, when it comes, for example, to machine learning, we have a tool that's focusing only on that. It's called Kubeflow, and currently they applied to reach the incubation level. If you have any batch workloads, definitely recommend looking at Volcano and Unicorn. Unicorn is coming from the Apache Foundation. Volcano is within the CNCF, currently incubation. Streaming. If you have any streaming you have to do for your data, Kafka is going to be your answer. Most of the users, they go for this tool. Storage. You can use any of the storage providers. However, Ceph reported a lot of success. And if you want to analyze any of the data that you gather and visualize it, you might use a tool such as Prometheus and Grafana. Now, Prometheus is going to be for data collection, and Grafana is going to be for data visualization. And if you have any artificial intelligence kind of workloads, you can go and see the Open Data Hub. This is pretty much a project that emerged from Kubeflow and allows you to run AI-specific workloads at scale. Now, as you can see, all of this is not as extensive, which means we definitely need your collaboration. If you have any interest in running your workloads in cloud-native way or on Kubernetes, please do contribute. Reach out to these projects, or if you have something that you would like to open source, reach out to CNCF or me. I'm more than happy to help with kind of getting this out there to the world. However, there's a sister foundation to CNCF, which is called the AI and Data Foundation underneath the Linux Foundation umbrella. Now, this foundation was created in 2016, 6 years ago, and pretty much tries to create this open space for AI and data communities to collaborate in. And currently, there are more than 400 projects associated with this foundation. Now, more importantly, they have a very similar maturity level as CNCF. So you have projects which are fully open source across sandbox, incubation, and graduation. So if, for example, cloud native is a world which is a bit too far from what you're doing day to day, we can definitely contribute and adopt these tools straight away. Now, more importantly, when you're talking about communities, open source, interoperability, sustainability of your community as well, this has been extremely beneficial for the world out there, especially the tech world out there. And for vendors, this translated into innovation. As a vendor, you don't need to reinvent the wheel anymore. You have standards and open interfaces that you can use straight away, which means that you can deliver value to your customer with minimal latency. When it comes to end users, all of this interoperability and open source community translates into extensibility. it was never as easy as it is today to benchmark different tools with the same capabilities. As an end user, as an adopter, you can choose the right tool for your infrastructure with minimal compromises. But more importantly, we have done that because we have this diversity of contributions from different organizations and different groups, and we still need to continue working on that and further diversify our executive leadership. Now, without saying, we are hiring. So if you'd like to work at Apple, or if you'd like to work within our AI/ML team, we actually have a senior engineering manager role open at the moment in Europe. So if you're interested, reach out to me. The job is posted on my LinkedIn profile, so you'll be able to find it there. But I definitely do invite you to maybe browse our jobs page. Definitely would recommend to work for Apple. If you'd like to keep up with any of my work that I do in Cloud Native, I have my Medium blog post, which you'll be able to pretty much see all of the latest trends that I'm exploring or any of the work that I'm looking at. And the next slide is not working anymore. That's the one. If you have any questions, I'm more than happy to answer them straight away. Or if you have any questions afterwards, I'm going to be available on LinkedIn and Twitter. Here's the QR code for the Cloud Native Fundamentals course. Again, free course, you don't have to pay anything. But if you know anyone who would benefit from transitioning to a Cloud Native journey and actually, learning the fundamentals, definitely recommend taking it. And please feedback to me as well. Now, this is Katie Gamanji, and I look forward to seeing how you can shape the Cloud Native ecosystem. Thank you, and enjoy the rest of the conference.